Hello everybody, this is Philip Jonas at Kalamazoo Valley Community College presenting OpenStax Principles of Economics, and today we're covering section 19.2, adjusting nominal values to real values. In this module, you will learn to contrast nominal and real GDP, explain the GDP deflator, and calculate real GDP based on nominal GDP values. In our last module, we got to know the national income and product accounts and our flagship economic measure, GDP. However, these NEPA tables present GDP not just in the way we're already familiar with, which is referred to as nominal, meaning it is calculated using the prices that prevailed at the time, but also in real terms, meaning removing the effects of inflation, which can cloud the data picture, which means they are also price indexes that can be computed. So let's talk about this word here, nominal versus real. Until now, the GDP measures we've discussed have been on a nominal or current dollar basis. And we want to learn about an alternative measure referred to as real GDP. Here, we're looking at how much more is our country producing compared to a reference year, which is sometimes referred to as the base year. These measures come in two types. Sometimes it's a quantity index, where we are setting our reference year equal to the number 100, and then we're saying relative to that number, how much did production increase or maybe even decrease. But more commonly, we use a technique called chained dollars, which means we're using the production of our reference year. We are looking at how much the production increased or potentially decreased. And then we are adjusting the dollar value of the reference year by the same increase or decrease. This is very close to saying we are measuring production using this year's amounts or quantities, but instead of the prices of this year, we are using the prices of the reference year. Let's discuss a little bit what this looks like in real life. In the previous module, we looked at table 1.1.5 of NEPA, the big GDP table. And you can see, for example, for the years 2021 and 2022, we have GDP measures of 23.594 trillion, increasing in 2022 to 25.744 trillion. The problem is, while each of these measures makes sense for the year in which they were produced, if we want to compare those two numbers, when we look at that increase of over $2.1 trillion, that increase is caused by two factors at once. In the year 2022, not only did our economy produce more goods and services, but the same goods and services also sold for a higher dollar amount, an effect referred to as inflation. So really, our comparison is not so good using these two numbers since we are measuring two changes at once. This is where the idea of real gross domestic product comes in. So first, let's talk about the quantity index version of this. As I mentioned, all of this is now happening relative to a reference year. So first thing you look at on your table is, what's my reference year? So right up here, Instead of looking at billions of dollars, we are now looking at index numbers. And our reference year is 2017, meaning in 2017, by definition, GDP quantity is set equal to the number 100. All other production totals are relative to this reference number. So for example, 2021, our reference number is now 109. That means there is 9% more production than in 2017. This number rises to a little over 111 in the year 2022. The change between these two numbers, take out your calculator, it's about 1.9%. That change now only measures one thing. How much more did our economy produce? So while nominal GDP is great for looking at one point in time in isolation, if you want to compare GDP numbers from different years, you really ought to use real figures. These are the index figures, but what you are even more likely to encounter are real gross domestic product figures using so-called chained dollars. So it's a very similar idea expressed in a different fashion. We still have our reference year. So that's the first thing you want to look for. What's our reference year? Okay, we're looking at billions of chained 2017 dollars. So what that means is we take the nominal GDP figure from 2017 and we increase it by however much production quantities have increased since 2017. So basically, we end up with this hybrid number where we are expressing production in 2021 or 2022 using dollar values. That's a little bit more relatable than using a quantity index. You know, what's 111, right? But $22 trillion, well, that's sort of got some meaning. But we got to be careful. It's not $22 trillion were actually spent in 2022. It's $22 trillion would have been spent in 2022 if we are removing the effects of inflation. Now, this actual technique of the chain dollars, it's a little bit complicated. It's something called a Fisher index, if you ever want to look that up on Wikipedia. But basically, chained means that we're not just comparing 2022 to 2017, our reference year, but that instead we are chaining forward the changes in our economy from 2017 to 18, 18 to 19, 19 to 20, and so on and so forth, which means slightly odd phenomenon. You see it down in the footnotes here of our table. Slightly odd phenomenon. If you add up our detailed sub-numbers, they no longer add up to the number at the top. That's totally okay. There's a lot going on here conceptually in terms of how you want to think about dollar values changing. So the entire impact of this change is noted in the last line 27 here, the so-called residual. If we're adding up the most detailed numbers, how different are they from the sum up top? But the nice thing is this is actually a great way of doing dollar chaining. And if you want to do some comparisons, and if it's for a detailed number, just use the detailed number. And if it's for the whole number, just use the big number. And it's okay. You're doing a sensible thing here. So this is our approach to real GDP. Now, when we look at these real GDP figures, and we now compute our changes in the number, and it's going to be the same change if we use the chain dollars or the quantity indices, they actually map to each other, This percentage increase is a super useful number because it tells us how much production increased in our economy while removing the effect of inflation. So as I had already previously mentioned, for example, going from 2021 to 2022, it is sensible to talk about this being a 1.9% increase. In fact, if you read about increases in GDP in, for example, a news article, and you see that percentage, unless otherwise mentioned, you can safely assume that it was calculated using real numbers, because that's the sensible approach. Now, as I mentioned, the chaining technique is a little bit mathematically involved, and it doesn't quite produce a result that you can interpret for numbers that can be negative. So if you look at our rows 14 and 15, changes in private inventories and net exports of goods and services, those are numbers that represent a difference. Those are numbers that can be negative. So you will notice those rows are always blank. No worries. That doesn't mean we're suddenly ignoring changes in inventories or exports and imports. That would be really bad. You can see in the numbers out of which they are computed, we still have the changes. It's just not showing up as a net. And likewise, that's also true in inventories. That level of detail just isn't reported in this particular table. Let us also look at these numbers over a longer time series using another graph produced by Fred. So here we have 21st century nominal and real GDP. Nominal in blue, real in red. First thing we want to notice, these two numbers are equal at some point. The lines cross. What's going on there? Well, that's of course the reference year 2017. By definition, real GDP is expressed in terms of our reference year. Now, once we move forward in time from the reference year, since nominal GDP uses current prices as opposed to chain prices, you will notice that since prices went up since 2017, the blue line is bigger than the red line. In fact, inflation having been a little bit higher over here, you can see they're starting to diverge a little more rapidly. But when you go backwards from our reference year, now we have to flip our thinking. So here, for example, is the 2007 GDP figure. The nominal one uses the prices of 2007. The real one uses dollars chained to 2017, which are going to be higher dollar amounts. So now the real GDP figure is the larger one. Also notice, during the recessions, these gray bars, quite often we have a big decrease in real GDP. Look at that red line dip, right? Only counterexample here, 2001. We had some decreases in real GDP, but they really didn't last long. Very mild recession here, relatively speaking. So while this chain dollar technique also produces a measure of how prices are changing, I mean, think about it for a second. We have nominal GDP, which measures changes in production and includes the effect of inflation. Real GDP, which removes the effect of inflation. If we have both numbers, we ought to be able to solve for what happened to prices, right? It is more common for us to do a price index based on the end result. This one is referred to as the implicit price deflator, IPD, or the GDP deflator, sometimes a little bit more colloquially speaking. So here's what we're doing. We are taking GDP measured in the nominal way and divided by GDP measured using the chained dollar, the real technique, forming a ratio. And then we are multiplying this ratio by 100, quite frankly, because numbers to the left of the decimal are just a little easier for our brains to work with. So that's just a little creature comfort right there. Let me show you how this is done using a number of values for the US economy. So here we've got nominal and real GDP in billions of dollars, as well as the deflator for the span of 11 years, with some strategic omissions of numbers so that we can calculate them. And we've got our reference. The GDP deflator, or implicit price deflator, is equal to nominal divided by real times 100. That means basically, if we know two of the numbers, we can solve for the third one. Let's start all the way at the bottom of the table by looking at letter J and getting to know the GDP deflator itself a little bit more. So when we look at 2022 GDP and we measure it using the prices of the year 2022, we get a number of $25.7 trillion. But if we instead measure the production of the year 2022 using chained dollars from the reference year 2017, GDP would instead be $21.8 trillion. That, of course, implies that prices in 2022 were higher than prices in 2017. Not surprising. How much higher? Well, that's what the GDP deflator tells us. So let's go ahead and solve for that letter J, or the GDP deflator. So our equation is already set up for that. All we have to do is plug in some numbers. 25.7 trillion for nominal GDP, 21.8 trillion for real GDP. Do the math, and the result for the GDP deflator is 118. Or let me phrase that as 118.0 to emphasize this is an index number. So there's no dollar value. It's definitely not a percentage. It's just a number. But what it tells us is that relative to our reference year, again, that's 2017, relative to 2017, prices are 18 points higher. So in 2017, we are forcing that deflator to be equal to the number 100 because nominal and real GDP are by definition the same number in 2017. So our reference number here is 100. And by the time 2022 hits, prices have gone up 18% under this measure. But of course, you might find yourself in a situation where you have to solve for one of the other ones as well. So let's run through every possible situation you could run into. What if you have to solve for nominal GDP, like in 2021? We know that real GDP was $21.4 trillion and our GDP deflator is 110.2. So now in our equation, we're solving for a number that's, not yet on the left-hand side of the equation. We're going to have to do a little bit of rearranging here. So let's plug in our variable and our known numbers. Variable we're solving for is I. Let's solve for I. That means we're going to have to divide by 100 to get rid of this and multiply by $21,408 billion, of course, which means I is going to be equal to 110 over 100 times the real number. Again, look what the math is doing for us here. The GDP deflator tells us prices are 10.2% higher than they were in the reference year. So if we are using chained dollars from the reference year, we have to increase that number by 10.2% to arrive at current dollar values for nominal GDP. That's this fraction right here. It's increasing the number by 10.2%. Or in other words, nominal GDP in 2021, $23,594 billion. Finally, we might be asked to solve for real GDP. Again, it's always best to start from the equation. So we have our GDP deflator equation and now real GDP down here in the denominator. So we're going to have to work a little bit to break that out. Let's start out by plugging in our knowns and our variable term. We are going to be solving for h right here. And of course, to solve for h, we're going to have to multiply by h to get it over to the other side, and then divide by 105.4 in order to get that over to the right-hand side. Or in other words, we take our nominal GDP figure, divide by the GDP deflator, multiply by the number 100, and the result is real GDP is about $20 trillion. Now, if you're a little bit worried about making a mistake here as you rearrange the formulas, again, always start from the base formula, absolutely a sensible approach, but also keep in mind what we're actually doing here. The GDP deflator is higher in the year we're looking at than in the reference year. Prices have gone up. That means nominal GDP is going to be a bigger number than real GDP, just like we saw on that Fred chart. So when you've got your answer, make sure it's a smaller number than the nominal number, otherwise something went wrong during the rearranging. All right, so this is how you do all three possible types of math. With this out of the way, let's now look at the implicit price deflators for our actual economy. And you can see, one of these we already worked out, of course, that prices have gone up since the base year or reference year, just like you would expect. And you even get nice subcategory breakdowns in case you're wondering about the development of prices in those subcategories. You can use these numbers, how prices have evolved relative to the reference year, to calculate a measure of inflation. For example, from 2021 to 2022, we've got over 7 points increase over a 110 base. Let me show you what such an inflation measure looks like in another table, 1.1.7. So this increase, 7.1%, this is what we would refer to as a rate of inflation. Now, small disclaimer here. When you read about the rate of inflation in the news, it's unlikely to be computed using the GDP deflator. We have another measure of inflation that is more commonly cited based on the so-called consumer price index, which we will cover in a future module. But there is a sub-entry here that I definitely want to highlight to you. Because while this consumer price index we'll be talking about is most commonly used to measure inflation in the United States, there is another inflation measure of the so-called cost of living. So what expenditures in the household look like. And that's if we look at one of the subcategories here of GDP, the personal consumption expenditures, often referred to using its algebraic letter C. There is a real argument to be made, and we won't get into the technical details here, that this is also a great, maybe even better measure of changes in the cost of living than the consumer price index. So our personal consumption expenditures deflator and the resulting inflation measure, that one you might hear about in the news. All right, let's look at the gross domestic product overall deflator then for the 21st century. So as you can see, first of all, inflation, using different measures, even, is not a super smooth and stable line. Prices can increase or not increase at varying rates even throughout a given year. But hopefully you can see a certain pattern here, a band within which we hopefully have the inflation numbers come in. Most of the time, they fall between 0 and 2.5%. In fact, when we talk about macroeconomic policy goals in our country, using the inflation measures that are more consumer-facing, like the consumer price index, personal consumption expenditures deflator, we often say that the target inflation for our country is 2% per year. Again, target, these numbers, they bounce around a lot, right? But what we mean is that's the neighborhood where we want to be. And most of the time, if everything is going well, we're pretty good at that. We're going to be talking, so how do you even target inflation? How do you do that? We'll totally talk about that. But as always with our graphs here, the COVID lockdowns and resulting disruptions sort of will ruin these charts for the rest of my career. Look at that big spike in inflation we experienced post-COVID. Right here, right? Almost 10%, even using this broad GDP deflator measure. But it looks like it's coming back under control. Finally, you will sometimes see inflation drop below the 0 line. So since inflation is the change in the prices, we're talking about falling prices here. Sounds awesome when you first hear that. Actually not awesome for an economy. We'll talk about it. This can be referred to as negative inflation, perfectly mathematically valid. But more commonly, we refer to falling prices as deflation. And while we had a couple of brief dips there, really the one just for, half a year sustained amount of deflation we've so far had in the 21st century is our financial crisis right there in the year 2009. All right. That concludes our discussion of module 19.2. In this module, you learn to contrast nominal and real GDP, explain the GDP deflator, and calculate real GDP based on nominal GDP values. In this module, you learn to contrast nominal and real GDP, explain the GDP deflator, and calculate real GDP based on nominal GDP values. See you next time.